Well, I was just getting my current vise ready to put on the mill. Using my speed handle here, I opened it all the way up so that I kind of got this centerpiece to move back so that I could expose inside there where I just got this ton of swaffits in there. I'm trying to scrape out. It's weird, on the jaw right here there's a magnet. Not sure why there would be a magnet right there. Both sides. Does anybody know what the purpose of the magnet is? Guess there's not much point in getting that spotless. I'm only going to get it dirty again, right? But the setup I got is I got my best test indicator on here, and essentially what I did was I just lightly bolted down the T-bolts, and I'm going to use my rapid traverse to go up and down, and essentially what I want is I want this indicator that the little finger is actually riding on the inside of this jaw on the vise. I want that to actually not move. So obviously if this is parallel to the movement of the table, then that reading shouldn't change. If this jaw is not parallel to the table, if it's tilted this way, then that's going to cause the reading to change, or if it's tilted this way. So you get the gist of it. So it's a matter of just kind of trial and error, playing with this thing to get it dialed in, and then once it's dialed in, I'll tighten these T-bolts down really well. A couple other issues I've run into here is I had forgotten about the fact that I've got the mill too close to the wall, so I couldn't get the ram all the way back. I wanted to get the ram back so that the front of this dovetail was flush with the front here. So right now I've actually got the table moved quite forward on the knee. Instead of back here under here, I've got it kind of out here. If I center the vise on the table, so right now I've got the bolts for the vise in the center T-slot. The jaws are, about here, so if I've got something in here, I don't have a lot of travel coming this way. I've got a mile of it back there. So ideally, I wanted this further back. Can't get the ram to go back any further without hitting the wall. Even to get it back as far as I did, I had to turn the turret. So now my head is over, it's not over the center of the table anymore. After going through all the trouble of tramming this thing, I ended up moving that. So hopefully that's not going to affect the tramming of the head too much. It is what it is. But the right way to fix this, and something I will probably end up doing at some point, is to move the whole mill out probably about 12 inches. So, we'll see. But, I put all my nice cabinets over here and everything, so that kind of stinks, but oh well. Poor planning on my part. Well, everybody, I just finished tramming up the vise. What I ended up doing is I've got this 1/2 thousandths indicator, a little ball feeler gauge. It's actually resting on the inside of the jaw of the vise, and all I do is run the table from one end down to the other. And originally what I did was I just saw how many thousandths difference there was between this end and this end. And then I just tap the vise with the mallet and nudge it over so that it moves the dial indicator back the other way, exactly half the distance that it had moved over its entirety. So split the difference. And do that about twice, First time it was like, you know, maybe 10, 15 thousandths. And then second time I got it down to about 3 thousandths. And then I did it one more time. And now I'm at the point now where if I zero that, I'm at still on 0. And then the only other thing is, of course, you're going to make sure that you're actually still on the touching the vise. So if I just barely touch it, you can see the needle moves. The other thing I could do is I could bring this up, move the saddle out, re-zero it, and that's 1 division, which on this particular indicator would be 1/2 thousandth out. So 1/2 thousandths over the length of the jaws of the vise. I don't know if that's enough to really get finicky about. I think I'm going to leave it right there because I already cinched it down because I thought it was actually even closer than that. But anyways, when I was cleaning the vise before on the video, I asked about the magnets, what the heck the magnets are for, and then I actually happened to be looking at something and I saw the like accessories for the vise, and somebody makes these little magnetic things that stick on the side here, and they're actually the parallel holders. So I'm assuming that's what the magnets are in there for. In other words, when you're putting your packings in there. Alright, decided I'm going to do a test cut on the Wells Index mill today. And I found this piece of stock right here that was saw cut on this side, and it's kind of ragged, so I just figured for the heck of it I'll face the top of that. And so I want to hold that in the vise, and because it's round, in order to get it to stay still, I'm going to use this old V-block and tighten it that way. Hopefully that's tight enough. See, a lot of guys put the handle of the vise on there and then bash the handle with a hammer. That to me just seems like it would be abusing a very expensive Kurt vise. So I would like to hear thoughts on that. That handle, you can get 2 hands on there and really get some purchase on it. So I think that's going to be good enough. What do I know? Find out in a minute, I guess. Alright, now let me go find a cutter, see what I want to use. Alright, so I guess for the first time using the mill, I'm going to go with this indexable face mill. It's got 3 carbide cutters in there. The cutters are used, but the tips do not look like they're broken off. So I think that should be okay. I guess I should know the diameter of this cutter before I put it in, so that I can kind of determine the speed. Now I do know some basics. I know that the larger the diameter the cutter in the milling machine, the lower the spindle speed. But I also know that if you're dealing with carbide, you can increase the spindle speed. So I think what I'm going to do is, I've got the original manual, reprint of the original manual for the mill, and I think I'm going to check that out and see what it says the maximum speed is for a 2-inch cutter, if it's even got that on the table, and then kind of figure it out from there. Maybe I can even just Google, you know, speed for a 2-inch face mill and get some recommendations there, and then I'm just gonna have to play around with the feed rate to figure out what, you know, what works. Jeez, looking that up on the internet, that's quite involved. Guys who do this for a living just know what to do, but boy, when you're a novice, or beginner I should say. So anyways, I think if I'm reading this correctly, I saw a chart that said cutting speed carbide through low carbon steel is, I think, around 200, I don't know, is that inches per minute or feet per minute? I forgot. But it's 200, and then you multiply that by 4, which is 800, and you divide that by the diameter of the cutter, which is 2, which gives you 400 RPM. That's for carbide. Well, I'm going to derate that to about 300 RPM, just because I'm a bit of a chicken. Now, I also read where you can't just slow everything way down and think that's not going to cause a problem, because if you decrease your spindle speed relative to your feed rate too much, then you run the risk of the cutters being forced to dig in too much and breaking the tool. If you decrease your feed rate too much in relative to the spindle speed, then that can create a situation where the cutter starts to rub instead of cutting a chip, and that can dull a cutter quickly, so that's not good. Of course, way too high of a spindle speed can burn up the cutter, you know that. I have no idea what to expect for feed rates, so I think what I'm going to do for the first couple passes is I'm going to manually feed the table. And I've got this in direct drive, which according to the chart up here on the machine, that's the lowest speed is 400, so I'm actually going to put this into back gear drive so that I can get that speed around that 300 that I was looking for. Alright, so my plan is going to be to just touch off on the edge there and then make a pass and then back it up and bring it up 10 thousandths. Yeah, that was cool. Alright, so I don't know, this whole climb milling versus conventional milling thing. I don't think I have to be concerned with that for the facing operation. So I think I should be able to now just bring the table up and go back the other direction without having to reverse the rotation of the cutter, which I could do, but actually the way the cutter's designed to go, I can see the way this cutter's designed. It's not designed to go in the other direction. It's definitely designed to go the direction I've got it going, because all the beef behind the cutter tip is behind it here, so this has to go clockwise. Alright, so let me set my dial at 0. Alright, and so now I'm going to bring the table up, you know what, 15 thousandths. Let's try that. This is kind of exciting. 20 more thousandths. Oh, I guess I should probably be locking. The saddle's locked. I don't think I need to lock the knee every time I do this. Alright. So now I think I'm going to try the automatic feed. I eased it back a little bit because I didn't like the noise it was making. This is really cool. So the leading edge of the cutter is off, so I guess I don't really need to let it go all the way off the end, do I? I will. What the hell? I cleared it. Alright, I'll pull that out under some better light and we'll take a look at the kind of finish I got on that. Hey guys, not too shabby. I mean, that's really kind of neat. It's, you know, got that sound of Velcro or corduroys. So, it's not perfectly smooth, but I mean, it looks pretty good to me. The hell do I know? Alright. Just for the heck of it, I'm going to take another 20 thousandths cut, depth of cut. I'm going to bump the speed up to what, according to the chart up there on the top of the mill, is 400 RPM. And I'm going to keep the feed rate the same. Safety glasses on. Yeah, there's that variable belt drive freaking out again. Alright, so I'm going to put it in direct drive, and that way I can run the speed lever all the way over to the right, which will be 400 RPM. I don't like how that is acting. I'm going to have to work on whatever the deal is with that. There we go. Spinning. I'm going to try 500 RPM. Can't remember if I brought it up 15 thousandths already or not. Guess not. It's about 15 thousandths right there. Oh, I didn't like that. All right. That's more like, oh! I put it in direct drive. That reverses the cutter rotation. I've got the cutter spinning the wrong way. Yep, that's the problem. One flick of the VFD takes care of that. Alright, there we go. Let's try that again. inadvertently hit the speed control wheel on the auto feed with my finger, and that feed rate started out way too high. Alright, so I'm going to take a lighter cut. Ten thousandths. I'm going to increase the spindle speed to 500 again. Keep the feed rate down. Actually, that's more about 600. Funny, the trailing edge of the cutter is actually taking a little. Alright. So I would definitely classify whatever that piece of metal is that I've got in there as free machining steel, right? I don't know, but the finish looks good. I mean, again, I don't know. I'm not a well, it's a sharp little burr on the end there. You know what it is? That mills didn't catch this very edge there. I guess I could clean that up if I want to get picky. I just moved the saddle over a tiny bit. I unlocked the quill and went to move it out of the way while it was still running, and I grabbed the handle pushed it the wrong direction, so I dug in there a little bit. But that's okay. I'm not making a part with this right now. I'm just playing around. So, all right. So I'm satisfied that I think the mill is currently in a usable condition, even though I've still got some issues up in that very top end there with that variable speed belt drive, and a little bit of squeakiness coming out of something up there, but that might be just I might have to readjust the brake. But alright, so I'm pretty happy with that. So I think for the moment we're gonna take another hiatus from the Wells Index Mill series. You're going to see the Wells Index Mill in some upcoming videos, but there are going to be more videos. You're going to see it probably featured in an upcoming Vernon lathe video, where I'm going to make myself a T-nut to fit the slot on the compound so I can put my quick change tool post on the Vernon lathe. And also, we're probably going to get finally back to the Atlas lathe. I need to make the bearing block support, or whatever you want to call it, for the lead screw on the Atlas lathe. And so we can get the Atlas lathe 100% complete and running, and then probably put some tooling together with that and put that on the market. Because I don't really have a use for that one now that I've got the Vernon running, and the Hendy will be, you know, eventually also online. So anyways, so I guess we're gonna call this a wrap for now. Oh yeah, so I do want to say that there are going to be more to this series, definitely. I've got some other things I want to do. I'm going to put the lights back on it. At some point, I'm going to revisit the issue I'm having with that, those noises and everything going on up there. I also am going to play around with that DRO that I got for free, the ancient DRO. Figure might as well see if I can't get that working, and if I get that working, I'll try putting it on the mill. And all right, so always looking for tips. You know, you guys have suggestions, feel free to give me a shout.